Hello, my name is Sergey Puzankov. I work at Positive Technologies company, and my responsibility is security research of signal networks in mobile operators and performance security assessment in mobile operators as well. First, a couple words about subject. This is SS7. SS7 it is a set of protocols in telephony that allows to set up and release calls, process SMS, and for mobile operators, this set of protocols provide mobility, roaming capabilities, and other services related to telephony, also to telephony. When SS7 was introduced, it was an isolated network from other world, and there were only limited number of players in this market who was connected to the SS7. So all security in SS7 was based on isolation and trust in the gentleman club. But later, in the beginning of this century, one more specification was introduced. It calls SIGTRAN, and this specification allows sending SS7 messages over IP protocol in telephony systems. And moreover, there are a lot of new players in global market who are connected to the SS7, such as mobile operators, mobile virtual operators, value-added services, service providers. And now we cannot say about isolation, because SS7 is connected to IP, it goes over IP, and the small club is growing up, and no trust anymore. And now, when some intruder connects to the SS7 inside one of mobile operator, he or she can attack subscribers around the world to mobile operators which connected via SIGTRAN lines, via old SS7 links, and moreover, this attacker can perform malicious activity against subscribers in LTE-only networks. LTE-only networks has another protocol for signaling diameter, but any LTE network has interworking function to connect to other mobile world like GSM and UMTS. Mass media and security researchers for recent several years focus attention on this problem, and one of the latest publication was on May this year. Some intruders, some hackers attack mobile operators of the United States and even governments concerned with this problem. Government and global organizations issued several documents regarding SS7 security or insecurity, such as Federal Communications Commission in the United States, ENISA, this is European Security Agency, and ENISA published their report on this year. And of course, GSMA, this is Association of All Mobile Operators around the world. This association issued a number of documents about security in signaling networks, and this set of documents covers all signaling protocols such as diameter, for LTE, GTP for packet data services, and of course SS7. Mobile operators are aware of this problem also. They started to protect their networks. They implement different security tools such as SMS home routing, SS7 firewalls. They introduce security monitoring. They configure the equipment with security standards. And they perform or order security assessment from external connections. And this is the most exciting part of my job. We perform this research from 2013 year, and from 14 year we started to publish our results of our research, and the latest one issued this year. It covers security audits for 3 latest years, and there are some interesting statistics. For example, mobile operators who are protected with SMS home routing solutions only are vulnerable to some threats, which is in rectangle, more than mobile operators without protection tools. During our research, we bypassed about 67% these solutions. One more solution, SS7 firewall. This is a rather young device or equipment in mobile for mobile operators. In our statistics, about 33% mobile operators has this solution in previous year. Regarding ENISA report, this digit about 40%, but it depends on say a set of operators. And now I need to describe some terms of telecoms, some identifiers, MSISDN. This identifier has a long description, but actually this is just telephone numbers which all we use to call somebody. GT, global title. This is address of any core node, and this address is very different from IP. Later I will describe this structure. IMSI, one more subscriber's identifier. But this identifier is signed on a SIM card. Subscribers do not use this identity, but this identity goes between core nodes to address a particular subscriber inside the network or between networks. Then nodes, STP, signal transfer point. This is just a switch for signaling traffic. HLR. This is a database of all subscribers. This database contains MSSDN and IMSI of subscribers, allowed and prohibited services, and the address of current MSC and VLR node. This is the next node. This node consists of 2 functions. MSC, Mobile Switching Center. This function is responsible for voice traffic switching. And the second part, VLR, this is a database. And this database holds a copy of subscribers' profiles from HLR. And moreover, this database has identity of the current base station. SMSC, SMS Center, this node is responsible for SMS traffic processing. And I mentioned IMSI. This identifier is interesting for intruders, because when he or she knows it, they can perform more attacks in mobile networks, such as location tracking, subscriber DOS, and others. In SS7, there are only 4 signaling messages that retrieve IMSI. First 3 of them should be blocked on the border. These messages should be used only internally in a mobile operator. 2 of them, 3, may be blocked on the HLR on a destination node. And the 4th one cannot be blocked, and the SMS home routing solution is used to protect networks against these malicious messages of this type. And the first example for today, how to bypass this home routing solution. But before I describe how SMS home routing works, let's see how just SMS goes in mobile networks. When SMS center have an SMS for particular subscriber, SMS center does not know where this subscriber is located, so this node needs to do a request for some information. Send routing info message is addressed by MSSDN. This is number of mobile subscriber. And this message comes to the HLR database. HLR responds with 2 parameters, IMSI of the subscriber and address of current MSC. After that, SMS center sends SMS message itself addressing subscriber by IMSI and sending it to received MSC address. And now, when a malefactor appears in a S7 network, he can abuse this signal exchange to retrieve IMSI and MSC address to perform all other attacks. And now SMS home routing. This solution introduces one more node, SMS router. And when SMS center sends send routing for SM message to the border STP, STP must route this message to the SMS router, not to the HLR. SMS router generates some fake IMSI identifier and sends it in response, and it sends own address instead of MSC's one. After that, SMS center delivers SMS to the SMS router. SMS router correlate this fake IMSI with previous MSSDN and performs one more SMS delivery procedure inside the home network. SMS is delivered to the MSC and later to the subscriber. And this signal exchange consists of 2 parts. First of them is on the external part, and the second one internally in the home network. So identities such as IMSI, MSC address goes only inside the home network, not on the external part. And again, intruder appears in SS7 and wants to receive IMSI identifier. He sends send route info for some message, but he has in response only fake data. Network looks like protected. And now I promised to describe in details identities. MSSDN and global title has a different structure. So all core nodes are addressed by number of digits like telephone number. It consists of 3 parts. First country code, 33, for example, for France. The second one, define network. This is network destination code, and other digits related to a subscriber. IMSI. This identifier consists also from 3 parts. mobile country code, mobile network code, and subscriber-related digits. On this example, mobile country code 208, this is also French country code, but digits are very different from MSA-SDNs. And there is a third type of numbering plans of addresses in mobile networks. It is a combination of previous two. It has a prefix from mobile numbers from MSA-SDN and subscriber-related digits from IMSI identifier. Since this is address, signal messages use these digits to reach mobile operator by this prefix. Then they use this type of numbering plan to apply appropriate rule on the border STP and use these digits to find appropriate HLR. Signal messages in this numbering plan, E214, are used to address HLRs only. No other, nothing other nodes. And now let's look at STP inside. When some signal message comes to the STP, it goes to a routing table. Routing table goes through own rules. If it met numbering plan E214, this table calls one more table, global title translation table, which defines appropriate HLR by range of subscriber digits. If STP routing table met operation code send routing for SM, STP sends this message to the SMS router in order to call SMS home routing procedure. Send routing info for SM message. It has the same identifier, MSA-SDN, this is the telephony number, on two layers. On addressing layer on the top, and as a payload on the application part. This is normal situation. And now if again intruder appears in SS7 and this intruder knows all this information, what he can do? He sends send route info for SM message addressing it in E214 numbering plan and use some random digits of subscriber-related IMSI and address target subscriber by MSA-SDN. STP goes to the routing table, finds that numbering plan is E214, calls one more routing table, finds appropriate HLR, and delivers this message to the HLR. HLR replies with correct data. SMS home routing is bypassed. And for this operation, intruder does not need to perform long brute force to find some IMSI. It's enough about maybe 5-10 attempts with randomization IMSI digits to reach right HLR. One more case, one more example. Again, it is connected with SMS home routing. When intruder appears in the SS7 and perform this action, intruder receives some data, but he does not know how signaling traffic goes inside the network. Is SMS home routing involved to the signal exchange or not? He needs send one more, the same message, and if in two replies he sees two different IMSIs, that means SMS home routing is involved in signal exchange, and the data he received are fake. And now let's look at one of protocol, TCAP protocol. This protocol lies between routing protocol and application protocol. It has one interesting parameter, application context name. Application context name corresponds to appropriate operation. For example, on this picture, send routing info for SM operation, and it should be addressed with application context name short MSG gateway only, one by one. This parameter consists of several digits. Only two latest may change regarding the operation. All digits above are constant for all mobile applications. And let's see what happens if we change one digit in a constant part. Again, our intruder sends send route info for SM message with malformed application context name, and it is surprised, but STP actually STP looks through signal message layer by layer. It goes through routing path. It defines a global title of destination HLR. And when STP analyzes application context name and it faces with not correct field, the software calls exception, and all other parameters in signaling message does not inspect it. After that, STP sends send route info or some other message to the destination node, because STP already knows about addressing. HLR, of course, responds with correct data, and the intruder needs to check if these data are correct. He sends one more the same message and receives the same identifier. That means SMS home routing is bypassed again, and it is connected with software bug on STP. One more case, SS7 firewall bypass. First, I'll describe the most typical deployment scheme of the SSM firewall. SSM firewall usually is implemented aside. STP, when STP receives any signal message from the external connection, it sends this message to the SSM firewall. SSM firewall inspects all the message, and if SSM firewall sees this message is hostile, it just blocks it. Otherwise, SSM firewall sends this message back to the STP, and the STP delivers it to the destination node. I would like to remind this picture. First message, send routing info. It should be blocked on the border only, because this message is responsible for a voice call. And now, again, intruder sends send routing info message. This message comes to the STP. STP routes it to the SSM firewall. SSM firewall understands that this message comes from the external connection and it should not be passed to inside the network. So SSM firewall blocks this. Again, I would like to remind this picture where we changed some constant part of the application context. What happens if intruder sends routing info message to the STP? This is a surprise, but STP again routes it to the destination node, to the HLR, and the HLR replies with the correct data. So SSL firewall again bypassed, and again, this attack is possible due to bug in configuration. Not in configuration, bug in the software. And the latest attack for today, position enhancement. Actually, location tracking attack in SS7 is most popular for intruders. The idea of this attack, intruder does not receive GPS coordinates of mobile device. Intruder receives identifier of the base station, and later he finds this base station on the map and suggests that target subscriber is somewhere near, plus minus maybe 100 meters in the city. But mobile device usually listens for several base stations of the mobile network, and if intruder is able to define all identifiers of all base stations, he can define subscriber location with better accuracy. We didn't come up with this attack. We found it during one of our security assessment, and we've seen strange picture. One subscriber received USSD notifications, a lot of USSD notifications. All of these notifications finalized with errors, and during 4 hours, on this picture from 5 till 9 p.m., these messages were sent from a lot of countries. You can see them on this picture. We investigated this problem deeper, and what we see on this picture, time schedule is different. Here is only 3 minutes scale of the timeline, and we see triples of attacks. First goes red, PSI completed. PSI, this is the abbreviation of provide subscriber information signal message that allows to get base station identity. This is location tracking. After that goes, this is strange aborted USSD notification and provide subscriber information again. So now we know mechanic of attacks of this attack, and we recreated this attack on a real network. On this picture, blue man is our test subscriber, red man is our tester, and our tester tries tries to recreate this attack. First, message provides subscriber information, and the tester receives identity of the first base station of test subscriber. After that, he sends unstructured SS notify. This is USSD notification message, but this message is without message itself, without USSD string. And please pay attention, even Wireshark defines this signal message as a malformed packet. But MSC node proceeds this procedure and sends a paging command to the radio access system. All base station from some area should send paging command via radio access, and the mobile device responds to the base station with the best radio conditions at this moment. We were lucky, and it was other base station. And now I omit some signal exchange because it is not sufficient for our attack. But finally, radio access subsystem sends error message that was translated to the our tester. That's why we saw all aborted unstructured SS notifications. After that, tester sends provide subscriber information message one more time and receives the second identifier of radio access subsystem. This is how it looks on the map. Two red circles defines the most effective coverage of two cells, but actually our subscriber is located somewhere in the green circle. And particularly this attack is possible due to software bug on MSC and VLR node. And what we believe that SS7 security has three main problems. First of them is flow of SS7 architecture. Then equipment usually are installed with a lot of mistakes in configurations, and equipment often has bugs in the software. Mobile operators often installing or deploying security tool think that they are protected. Nobody can hack them, but I again want to remind about 67% of SS7 home routing bypassed in our tested network. What operators should do? First, test the network to understand which potential vulnerabilities exist. And they need to discover and close these vulnerabilities before intruders find and exploit them. And of course, operator should know the perimeter from signal networks also. They need to monitor external signal links to understand if installed security solutions work properly. And that's all. Please, your questions.